Hi everyone, this is Giri, lecturer in physics. Welcome to Expertisor Academy. Now we discuss about the capacitors in series and parallel combination. First one is capacitors in series. Capacitors in series combination. So consider three capacitors C1, C2, C3. These are the symbols of the capacitors. So here for C1 plus Q charge is inserted in this plate of the capacitor, minus Q charge is inserted here. At the same time, C2 and C3 capacitors are having the charges. Okay. So consider two terminals in any capacitors, two terminals in any capacitors. The combination, that is series combination. So how to identify that combination or how to arrange that series combination? So what is the meaning? The series combination. So look at here. Consider this is the first plate of the capacitor, this is the second plate of the capacitor. This is the first and second plates at the same time for third capacitor also. Second plate of the first capacitor is joined with first plate of the second capacitor, and second plate of the second capacitor is joined with first plate of the third capacitor. Now these three capacitors in series combination. These three capacitors in series combination. What is the meaning of series combination? Second plate of the first capacitor is joined with first plate of the second capacitor, and also second plate of the second capacitor is combined with first plate of the third capacitor. So this is the series combination. These three are arranged in between point A and point B. Negative charge terminal of the third capacitor is joined with negative terminal of the battery. Positive charge of the first capacitor plate, that is joined with positive terminal of the battery. So here the negative charges enter from negative terminal of the battery to negative charge plate of the third capacitor. This negative charge pushes the negative charge to the positive terminal of the third capacitor. This charge flows to the negative charge of the second capacitor, and also this negative charge flows to negative charge of the first capacitor. So like that, this charge is flowing through these three capacitors. So here the amount of charge which is given by the battery is same, but two different types of charges are inserted to different terminals of the capacitors, that is positive and negative. Okay. The charges of the capacitors same. Next thing, the voltage in three capacitors is different. That is V1 for first capacitor, V2 for second capacitor, V3 for third capacitor. V1, V2, V3. By using these three sum of the voltages, this sum of the voltages of the three capacitors, that is equal to voltage at battery. Voltage at battery. So this is the equation for this statement. V is equal to V1 plus V2 plus V3. This sum must be equal to voltage at battery. So we know that capacitance formula. Capacitance C is equal to charge divided by voltage. Capacitance C is equal to charge divided by voltage. By using this equation, V is equal to voltage V is equal to charge divided by capacitance. So that's why V1 is equal to Q divided by C1, V2 is equal to Q divided by C2, V3 is equal to Q divided by C3. Q divided by C1 plus Q divided by C2 plus Q divided by C3, here Q is common that term. So remaining one is 1 by C1 plus 1 by C2 plus 1 by C3. This reciprocal sum of the different capacitors of its capacitance must be equal to reciprocal of equivalent capacitance, that is 1 by C equivalent. So here V is equal to charge divided by capacitance, that is equivalent capacitance. So that's why this equivalent capacitance must be equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus and so on. If there is a 4 capacitors, another one of the term, that is 1 by C4 is inserted. So this is the combination of the series for capacitors. So next thing is capacitors in parallel. Capacitors in parallel. In series combination, we have three capacitors. Like that, here also we have three capacitors, C1, C2, C3. By using these three capacitors, C1, C2, C3, here different types of charges, I mean different amount of charge is passing through different capacitors. In series combination, same amount of charge is passing through two different capacitors, but here different charge is passing through the different capacitors. Okay, so this is the battery and this is the key. Okay, so how to identify the parallel combination for three capacitors? Three capacitors, it's not a mandatory. Two or more, that is our wish. Okay, see here, these all are the first plate for the capacitors. These first plate of the capacitors are combined at the one point. Second plates of the all capacitors combined at another point. So that's why this is parallel combination. Okay. Here voltage is same for this total three capacitors. Why? Because voltage means potential difference. It creates two ends of the conductors only. There is a three capacitors, okay, but here only having two endpoints. So that's why voltage is same. So by using this concept, the charge which is developed by the battery, that must be equal to sum of the charges at three different capacitors. That is equal to total charge, that is equal to Q1 plus Q2 plus Q3. See this one, total charge, that is equal to CVT, that means total voltage into C. Here total voltage or voltage at three capacitors must be equal to V only. So that's why at the place of Vt, V1, V2, V3, enter V. So that's why this V is common here and cancel with V. Now C is the total capacitance, that is Ct. This one is C1, this one is C2, this one is C3. So that's why total capacitance, that is equal to C1 plus C2 plus C3. So in parallel combination, capacitance and charges are different, but voltage is same. In series combination, capacitance and voltage are different, but charge is same. So this is the capacitors in series and parallel combination. So in series combination, the resultant capacitance of the capacitors, that is the reciprocal sum of the individual capacitance of the capacitors must be equal to equivalent capacitor, that must be reciprocal. But in parallel combination, the direct sum, the sum of the two different capacitors must be equal to total capacitance. Hope you all understand. Thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.